This video continues with the solutions to exercise set 4. And we're now looking at the 10,000 foot long, 72-inch diameter riveted pipe that carries water at 200 feet cubed per second for Chesney Manning. First, we're going to need to have the loss model, and that is located on our class website. And review of pressure pipe systems. I think it'll be in this lesson, lesson number 3. Let's grab the PowerPoint slides. That should be the fastest. Wait for it. And down here should be loss models somewhere. We want that one. And let's hope that that's the one for US customary. We're going to need a tool to evaluate that. Fastest way, I guess, is to build one in Excel. So let's go ahead and put our model together, and then we can test it using an online calculator, and then we'll know if it's a SI or Excel. So we need to know length, discharge, hydraulic radius, diameter, D-I-A-M-E-T-E-R. There we go. Area. Having trouble with the spelling. Area. Okay. Hydraulic radius. We'll compute a velocity. Manning's N. And that should take care of it. So in our case, our length is 10,000 feet. Our discharge is 200 cubic feet per second. The diameter of our pipe is 6 times 12 is 76 feet. The area equals pi times that squared. That's all divided by 4. Wetted perimeter is going to be pi times the diameter. Hydraulic radius is equal to the area divided by the wetted perimeter. All right, velocity is equal to discharge divided by area. Velocity squared is equal to that squared. R to the 4/3 is equal to the hydraulic radius raised to the 4 divided by 3. Manning's N, 0.033. We'll go look that up. That's in a second. N squared, that squared, and head loss. Okay, it equals the length times N squared times velocity squared divided by 2.22 times r to the 4/3. So head loss in these conditions is 142 feet of head. Let's go ahead and assume that that is indeed the, since I don't know, I'm going to pretend that it's US customary and apply the same information. 6-foot diameter pipe, 6-foot flow depth. Use my online calculator, and I now have my hydraulic properties. Go to my slope area discharge calculator, Manning's N of 0.033. We'll grab the flow area of 28.27. That agrees with that. We will grab a wetted perimeter of 18.849. We'll use a dimensionless slope of 0.0142, and lo and behold, we get a discharge of 199.29. So oddly enough, Manning's equation applied to this problem produces 142 feet of head loss. And we could have gotten it directly from here because the friction slope is simply the head loss divided by the length. So it would be the head loss divided by 10,000 feet. So if we multiply 0.0142 times 10,000, well, there's 10, 100, 1,000, 10,000 to be 142 feet of head loss. So we'll go ahead and just put in the 142, and we'll see that Manning's equation produces quite a different result. Using that high value Manning's N. Now if the Manning's N value is lower, it might be quite a different result. Let's go ahead and do a different value of Manning's N. Do a nice smooth pipe, and our head loss is quite a bit. Let's see, there's too much flow. So if the pipe's a lot smoother, it's getting close. Might put 24. Okay, that's close enough. 207. I'll go to 0.23 for those of the people that really. Okay, so discharge at 203 is close to 200. So 10, 100, 1,000, 10,000. If Manning's N is 0.013, then the head loss for the system is 23 feet. We'll go ahead and, since we did the work, and it's about 23 feet, using so the Manning's equation is probably not the best model for this application. But the point being, if the roughness is smoother than was suggested by the online value of Manning's N, we have three numbers that are kind of in the same ballpark.